Hello. In this video, we will take a look at a homework problem where we have to find um, the the critical values chi r or chi squared left, chi squared right, and then find the confidence interval. All right. Oh, we're going to do this with the help of StatCrunch. And so let's get StatCrunch going. Let's put that a little bit here on the side, and we will be accessing the calculator portion of StatCrunch. All right, first thing that they're asking is the degrees of freedom. So the degrees of freedom is n minus 1, n is 24, so our degrees of freedom must be 23. Now that we know that, we're going to look for the chi-square left and chi-square right. It's kind of difficult to look for this using your TI-84, 83 calculators, and that's why I'm opting to use our StatCrunch program. And our StatCrunch program, once you get it running, has a stat and a calculator option. And these are all the statistics calculators you can use. And we will choose chi-square for our chi-square values. We're going to find the standard measurement of chi-square. And we're going to first enter the degrees of freedom, which we just found to be 23. Now, the x value here, actually, it's supposed to be chi. And this number here is going to be our critical value. And the number that it's equal to is going to be the area or the probability. So in our particular scenario, we want a 95% confidence. And so we have to imagine that the chi-square distribution will have the 95% shaded region in the middle, and then we want to look for the tails on the outside. So if there's 95% in the middle, the two tails would make up 5%, and we need to cut that in half because one's going to be on the left and one's going to be right. So half of 5% is 0.025. So let's put 0.025 for the 5%. And we want to look for the area that's on the left side of it. So we'll keep this less than symbol and we'll ask it to compute. So you see the shaded region, and this is going to be the critical areas on the right side. And the shaded region here is going to get cut off by this number. That's 11.6885. So if we just copy and paste that and make sure that we round off appropriately, we want to round off to 3 decimal places. So we have 8 and it follows a 5. So we'll go up to 9 for this distribution. All right, we'll do the same thing. This time we want to go on the other side. So we'll switch the symbol, the greater than sign, and we want to make sure that we go back to, we'll erase this again, and we'll go back to 0.025 and then compute, and we get the chi-square right value. Again, we're going to round off to 3 decimal places. So we have a 6 in the 4th place. We'll put the 5 up one more, make that a 6. And we have our second critical value. Now we can use the formula, since we've already found this, we can use the formula to figure out our confidence interval. But instead of doing that, since we do have StatCrunch already up and running, we will use StatCrunch to go ahead and find out this confidence interval. So we're going to click on stat again, and this time we're going to go to variance stat. Now notice that this is the variance, not the standard deviation. So we'll worry about that when we start putting in our numbers. We don't have the data. We do have the summary, and the only summary pieces of summary we need are the N and the S. So the sample size, let me start with the sample size. That's obvious, it's 4. Sample variance is not 65.4. that is the sample standard deviation. So to get the variance, we're going to take out our calculator and put 65.4, and we'll square that. So that's 4277.16, 4277.16, and that is going to be our variance. Now we will be doing a confidence interval. In the next chapter, we'll be doing a hypothesis test, but for now it's a confidence interval, and we'll go ahead and compute. Okay, the values that we're getting here are actually the the confidence interval for the variance. And so we want to just undo the variance to go back to undo the square of the variance to get back to the standard deviation. So for example, the left lower limit, the lower limit on the left side is 2583.6654, and we want to include as many decimal places as possible, and we'll take the square root of that. And then we get 50.829, rounded off to one decimal place, that's 50.8. And then we'll do the same thing with the right side. The upper limit, according to our result here, is 88,416. 0.3274, and again we'll take the square root of that. We're going to get 91.7. 91.7. All right, and that should be it. Okay, I hope that helps. Good luck.